Okie dokie, ladies and gentlemen. Here we go. Questions on those? None? Y'all are smart. Or y'all are scared to ask anything because I got the recorder on. You're like, I ain't getting on that thing. Okay. Woo. How about them? Nope, you didn't get those, or no problem. You get 7 right? Yeah, all right. You got 7 right. Oh, man. Okay, so raise your hand on how many people missed number 5. Really? That's quite a tremendous amount of people. So let's see, ladies and gentlemen. Here we go. Now, how do you multiply radicals? Outside to outside, inside to inside. So, we can do a couple of different strategies here. Watch me. We can, here's 1. So we can do 1 times -3, which is what? -3. Then we can do, this is what's in the radical, right? That's the radicand. So 6 times 6 is what? 36. I have an a times a cubed, which gives me a to the what? Okay, ladies and gentlemen, after I've multiplied it, what do I consider? Simplification. Simplification. Okay, can I simplify 36? Why? It's a perfect square. So that's automatically going to come down to just 6, right? Now, I can expand the a to the 4th. Okay, so let me show you what I mean by expand a to the 4th. So if I have this is a to the 4th, so I can really go a times a times a times a. Now, what is my root or index? What's 2? So that means I have to have 2 of the same things to make a grouping, right? Okay, so here's 2 of the same things. So that's 1 grouping. Here's 2 of the same things. That's another grouping. So how many groupings of a's do I have? Okay, so I can pull out a squared. A squared. Out. Do I leave anything behind? Is anything left behind? Okay, good. We're not in the left behind series yet. So, what's another way to think about it if you don't expand it? Two, which is the root or the index out here. It's imaginary, right? How many times would 2 go into 4? Twice, so I can pull 2 of those a's out, right? Is any of them left in? No. The only way you'll have one left in there is if the powers that are there are odd, right? Yeah. Okay, good. So that gives me -3 times 6 is what? Okay, so what happened? Where did the wheels fall off? I've got different colors. Was it on the red? It was on the red. It's most. All right. Okay, so you know where you went wrong. Anybody else? There was a lot of hands went up on this problem. Okay. Anybody else? Good. We'll compare your work to mine. You've got to be able to, you got to be, even if it's wrong, you got to be able to say, okay, the first step that the teacher made was this. How does that compare to mine? Is it the same or is it different? You got to be able to compare and contrast and analyze. Y'all do that a lot in the English stuff, right? Write papers to contrast, compare, analyze, right? Yeah? Y'all also do that in science class, do you not? Yeah? Okay. So let's go back to where we're at. Okay. All right, so that was which one? 5. We're good on 6? Yes or no? Take 30 seconds to look at number 6. Come on. If you've missed it, take 30 seconds to fix it. Because if you don't fix your thinking, guess what's going to happen? You'll go right back down that rabbit hole that got you to the wrong place. You got to undo those connections and make new ones that are much more successful. Right? We will always, well, let's see. Do we have anything on the outside here? Ones. What's 1 times 1? 1. So that makes sense that there's a 1 here. 3 times 5 is what? 15. Good. M cubed, M gives you, or M squared gives you M to the what? 5th. Now, why was I able to pull 2 of them out? 2 goes into 5 how many times? Twice with how many left over? Does that make sense? That's M squared with an M inside. Are y'all gelling now? Much better? Do what now? No, you can never have unnecessary math. Oh, yeah. It's those rules of math that kind of get you if you don't do it right. That's okay. Okay. 8 is distributed. I'm going to tell you something. On the quiz tomorrow, you are going to do a distributive. Every bit of this that you've done this week will be on the quiz tomorrow. Okay? Yeah, that's what we're going over. Anybody got one suggestion on how to make 8 a lot simpler? Anybody? Distribute right. Well, if you distribute right, you're bound to get it right. Yes. Yeah, we are. I just made it go down there so that it's not up there. Is that okay? Yeah, sure. I just minimized it. It's less stressful for y'all. Because if y'all see that, y'all are hesitant. Hey, listen, this is not going to pick you up anyway. I know. It's like, I don't know, 1.5 inches, 2 inches from my mouth. It's going to pick me up, and I talk kind of loud. Y'all, not so much. Okay. Y'all ready? I put my 1s in there, right? Okay. Here I go. What's -1 times -1? And I'm going to put it. Why am I going to put it? So I know it's there. Now, later on, I'll get rid of it, right? But that lets me know that, hey, what I'm doing is right, okay? It builds my confidence up. Now, square root of 10 is square root of 100, guys. And you should know if you multiply the same radicals together, you're going to get a perfect square, which is then going to reduce back to the radicand that was there, right? So you should know that that square root of 100 is going to go down to what? 10. Good. Okay, we'll finish it. Okay, now, let's do the last one. Ready? Because we did this, right? There. Now I'm going to change colors. And do I have a radical on the last one? No, that 3 is all by itself, right? Is that what got you? Look. If I gave you this and I said, okay, you got to multiply that, that's the same thing. But it's got a radical, right? So you got to think about that. I'm only going to multiply insides to insides, outsides to outsides. So -1 times 3 is what, ladies and gentlemen? -3. What happens to the square root of 10? It just comes along for the ride. -1 times -1 is 1. Well, I'm not done. I'm going to do some stuff. Can I simplify square root of 10? How do you know? One of its factors, let's talk math to me. One of its factors is not a perfect square. That's how you know. Yes?
I thought you said if at least one of the factors was perfect square.
You find me a perfect square that goes into 10, please. 2 is not a perfect square. What times itself will give you 2? Perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256. Those are perfect squares. Okay? Listen, y'all remember songs, lyrics to songs. If you would take, how many of y'all are iPhone users out here? Lord have mercy, we'll pray for you. Now, how many of y'all are Androids? How many of y'all are smart? Hello. Holla, holla. Higher learning. Whoop, whoop. All right, now, shh. Focus. Listen, every one of your phones have a voice memo, right? All you got to do is record yourself on anything you want to remember. Record yourself. Listen. You don't like working smarter. You like working harder, right? Okay, but listen to me. Record it, and then all you have to do is hit play. What happens if every time you listen to it, it goes where? It's like the lyrics of a song, is it not? After a little bit, you're like, oh, blah, 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 blah. I know. I mean, you can walk and talk about radicals all day long. It is so great. And then you can hit rewind and hit play again and hear that story over and over again. Like my voice now. Now. Okay. Boom, boom. That's 8. There. 9, 10, 11, 12. A lot of prayer session going on right there. Lots of prayer session. Oh my. How we doing? You got everything wrong? Now come on. Okay, guys. No, you can't stop midway because the problems after it are not going to be identical. What is the difference between 9 and 10 compared to number 8? Nothing. What is 11 and 12 really doing to it? 12 really is not any different. 11 is not any different. It looks scary, does it not? So would you like for me to show you a strategy on how to break that down? Let's break it down. You ready? Here we go. Okay, well you ought to got 11 right. Which one do you want to do? Does it really matter, 10 or 12? Which one? All right, let's do this. 10, raise your hand. 12, raise your hand. 12's unanimous. There you go. Okay, so I'm going to show you something. I showed you a strategy with marking different things and showing loops, right? So we're going to break it down. Remember, this is a monomial, one term times, or going into, or multiplied, distributed into 2 terms, right? So let's think about how we can rethink this. I'm almost done with it. I said last night, God honest truth. I got home because it came a flood and we stopped. I got home about 8:20. I laid in my chair. I sat down in my chair, took my shoes off, And Jenny woke me up at 10:30 and said, you need to go to bed. I got up and walked to my bed, and that's the last thing I remember. I'm thinking she's drugging me, but my plan was to finish up last night. No, I've just been working a lot this week. Besides here, I've been doing other stuff. So, but that's not an excuse. It is what it is. Okay, y'all ready? Some of y'all have been with me this week, have you not? Some of y'all have different things. Huh? I know. And that is a wonderful thing. Okay, y'all ready? You can... What am I doing here? I'm just showing you. Isn't that what you're doing? So I'm considering one multiplication at a time, right? So what's outside's here? Right here. -1 and 1 is what? -1. 15 and 5. 75m, right? Okay, good. What about this one? -1, 45? 45m? Okay, now, when you hear 75 and you 45, what's popping in your head? 9 and what? 25. Y'all starting to see those? That's good thinking right there. All right, what do you think about this? Well, so here. So I've got it now. I've just taken them and written them down. I took the top one, put it first, took the second one, put it last, right? That's a good strategy. Or you can use the little loops. It doesn't matter to me. You're doing the same thing, are you not? Yes or no? Good. So, at this point, all I'm doing is breaking it down, baby. Doing a little break dancing right here. Breaking it down. Here we go. -1 times square root of 25 times square root of 3. What do you want to do with that m? Do I pull it out or do I just leave it there? Why do I leave it? There's only one of them, and I can't get it's not a multiple of 2, is it? It's got the power has to be above 2 for it to be a multiple of 2, or to be able to pull out at least one grouping, right? Does that make sense? There you go. See, I'm getting you to go. So I'm just going to leave this times square root of m. Is that okay? Y'all okay with that? All right. So now here, let's change colors because I like. Okay. So we're gonna go. So -1 times square root of 9 times square root of 5 times square root of m, right? So here we go. -1 times 5 times square root of 3m, right? I'm just going in and combining those. And then I got -1 times 3, right? Well, I better pull that down, right? Times square root of 5m. And now I'm just going to finish my answer, which would be -5 square roots of 3m minus 3 square roots of 5m. Can I do anything with that, ladies and gentlemen? Ladies and gentlemen of the mathematical nation, can we do anything further? Nope. How do I know I'm done? Because it feels like a good time to just stop and pray, right? I can't simplify anything else in that radical, right? And I've taken care of my variables. I can't combine them because they're not the same. There's nothing else that I can do to them. So it's time to walk away. you're done. That's what you got to do. Now, what I encourage you to do is this. I need you to go back when you're studying tonight, because we're going to give you a cumulative review type thing. It's going to kind of break down. We'll look at different things. We'll talk. And we'll see how much you've gained in knowledge. But I want you to, when you're working back through some of these, and you should spot work different problems on this. I want you to think about your thoughts on why you're doing what you're doing. Because if you understand why you're doing what you're doing, then when you have another one, that's just a change in numbers. Because really, that's all it is, guys. In math, all we're doing is changing the numbers. That's it. You know you're going to have to simplify some things tomorrow, right? You know you're going to have to simplify things that have a radical. Have a variable in it, right? Yeah. You know you're going to have to add some radicals together. But before you do that, you can only add them if they are the same, right? You know you're probably going to get a perimeter question, right? Guaranteed. You're probably going to get an area question. Me too. I like the word problems. It's real life. And then you're going to get, let's think about this. Let's think about the progression we've had through the multiplication. Two things times each other, right? And then a monomial times a bi, right? Have we done the bi times the bi yet? Is it not on here? That's 12. It's not. But it could be. What would be any different? Nothing. It just would be a little more space on your paper. But if you organize it, you can do it, right? Yeah? Okay. You should have been okay on the rest of these. Yay or nay? Because we done how many off these? 13, 14, 15, 16. How many did we do off this? 2 of them? None? We didn't do any of these? Find the area. Uh-oh. I thought we did. Oh, did I not ask y'all? Were you okay on the back, y'all? I could have sworn I asked y'all. I have to go back and check that tape. Wait, I can't. There's no audio. They say that the mind's the first thing to go. Right? So, okay. Now, area is length times width. So let's plug in our stuff. Our length is what? 3 square roots of 8. And my width is 2 square roots of what? 5. Outside to outside, inside to what? Inside. So 3 times 2, square root of 8 times square root of 5, right? 3 times 2 is 6. Square root of 8 times square root of 5 is what? 40. Now, can I simplify 40? What's wrong? Is that not number 13? That's not what you done? What did you do? You put a 4. When you wrote 8 down here, you put 4 the next time. You don't see your copy in there. 3 square roots 8. You wrote 3 square roots of what? And you did 4 times 5. Your process was right. You just made a copy in there. All right, y'all ready? How can I break this down? 4, yeah. 6 times square root of 4 times the square root of 10. That becomes 6 times 2. Can I break 10 down? 4 won't go, 9 won't go. I'm done, right? Yes, good. So, ladies and gentlemen, that's 12 square roots of what? 10. What does this 12 square root of 10 represent? It represents the area. Good job. No. You've got to know that I was wrong up to that point if I didn't do what? Simplify. Yeah, you should have been saying, hey, Palmer, you ain't done with this problem. Get back up there. That's what you ought to say it. All right. What about the rest of them? Oh, I can't show you the answers because guess what? Oh, I can. Here, let me do this. I'm very quickly show you what it ought to be. Now, I'll set it up and I'll do some stuff, but you're going to have to fill in the blanks, right? And filling in the blanks is not going to be that hard for you. Okay, we've done this one. This one becomes square root of 5 times square root of 15, and that's square root of 60, right? Oh, my bad. I can't even add right. Yeah, you're right. It is multiplying. What was I talking? Okay. I can break that down into square root of 25 times square root of 3, which is 5 square roots of what? 3. Good. Thank you. Questions? What about this number 15? I've got its length, width, find area. So square root of 6 times 6 square roots of 12. That's 6 square roots of 72, ladies and gentlemen. Ding, ding, ding. What times what to give you 72? 9 times 8. You'll probably go to 9 first, right? Let's just think about it. Because 9 times 8 is 72. That's something that we're automatically going to think about. So 6 times square root of 9 times square root of 8. So 6 times 3. Can I simplify square root of 8? I still can. You always have to check the radical that's left, right? That's right. Do not make that mistake and go, I simplify one. You got to make sure it's good on the other. So this would be square root of 4 times square root of 2, right? And we know that square root of 4 becomes what? There you go. So 6 times 3 is 18 times 2 is what? 36 square roots of what? Thank you, ladies and gentlemen. All right, but you need to look at my work, think about my thoughts, and see how they differ and how are they same.
Wait, it's 36. You did not 2.
Yeah, 36 times 2 is 72. So could you have simplified it a lot quicker with one step? Yes, you could. But majority of the time, guys, when you see 72, you're not going to think 36 times 2 because your brain is not trained on that. When you see 72, what are you going to do? 9 times 8. And that's okay. 9's a perfect what? Square. Well, you're more advanced on your multiplication facts probably than most people then. Fair enough? Nerd up. Good. So 5 square roots of 3, square root 27, right? All right, length of rectangle is that. Width is square root 27. Find the area. Bada bing, bada boom. That's 5 times 1, right? You say, Palmer, how you know that's 1? Because anything's outside the radical that's not there is just like a coefficient of a variable. It's a 1. What's 3 times 27? Man, that is a perfect square. Will you see that again? No, certainly, ladies and gentlemen. Okay, you good? That's all of them, is it not? All right, oh my, you good now? Lord help us. All right. There. That is 4x square root of 5. This is 4x square root of 5? Yes? Yes? So answer to this one's 4x squared 5. You can double check me. Please do. And then the other one, let's see if I can do it, and y'all can verify here in a second. And then this one is, that's 32x squared, square root of 18, square root of 9 is 3. 3 times 32 would be 96. X squared, square root of what? 2? Is that better? So you at least know, I didn't show the work on the last two, but what I didn't show the other stuff.
You get that bottom part.
Which one?
The hand. How doing his work.
32 times square root of 9. Square root of 9 is what? 3. 3 times 32, bro.
Oh,
Yeah, that's... No. I can split 18 as into square root of 9 and 2, right? Oh. Yeah.
you got it right there.
You got to. Okay, guys. Here is the cumulative review that you've got. So I'm going to look. Look right here. We're going to work number 14. Okay?
Oh, wait.
And then we're going to look at some nerding out opportunities on the other. No, we've got to nerd out. I've got to have at least one nerd out time a day. Yeah, it does. I prefer it to be from y'all. I'm kind of jealous like that.
I don't understand why you said you hated school.
Yeah, I did. I don't know why. You love math now? Is that what you're going to tell me? Why you have to do work? Why? Okay, but it's not from going home and setting my tail down now, is it? Let's be honest. All right. Y'all good? Every day above the ground's good, brother. Okay. Lady, I can't count. Just pass the extras back up front. Okay, ladies and gentlemen, I need you to work number 14. Ladies and gentlemen, work number 14. Please understand that, yeah, okay, you can probably scratch number 8. And you can't, 300's not that bad. You think about it, you can do number 5. But you can scratch number 8. I don't, well, you know what?
How about we scratch them all?
It's number 8, if you look at it, you ought to think about it and be able to go, it's a big number, but it ought to simple. Okay, but let's think about what 490 is, guys. That is 49 times 10. 49 is a perfect. Okay, so, why. Now, 14, go. Come on. Oh, hey, gentlemen, let's see what you can do independently, and then I'll allow you to check yourselves. Okay? Come on. Cumulative means all together. Everything that we've done, right there. Think about it. Number 14 is what you need to be working on. Okay? Did anybody split it just like what I done?
No.
Okay, I'm gonna highly encourage you. That makes life a little bit easier. Think about how we talked about this when we done binomial times a binomial, right? You go, well, Palmer, I like to do the arches and everything. That's wonderful, but these are radicals, and it can get pretty crazy up in there. Yes, ma'am. That's the first term on the first parentheses times everything in the second term. Then the second term times everything in the second parentheses, right? Oh, that's how we broke that up, right? Yeah. Now we're cooking with some grease. Here we go. That's good stuff. Anything fried is good. Even your brains. We try to fry your brains every day to make you think a little bit deeper and harder about math. Ladies and gentlemen, boys and girls, I'm not done yet, but look at my green. One more step, and life is over right here with this problem. 26 plus 11 square roots of what? Done. How do we do? Move this side? Okay. All right. Y'all good? All right. Digest it. Go ahead. Go ahead. Do it again. I'm slow. No. No, there's a certain way to do it. So. Yes, sir. Go ahead.
Why didn't you multiply the square root of 2?
I did. I got square root of 4. Right? Square root of 2 times square root of 2 is square root of 4. Well, when you take the square root of 2 times the 3, because I have an outside and inside, I just join them together. It's no different than taking 2 times x. They become 2x, right? The square root of 2 times the 3 becomes 3 square roots of 2. And look at what's smack dab in the middle. What do we call those? Like terms, ladies and gentlemen. They're underlined. That's why I done that underline. Yes, sir. Because when we multiplied binomials back in the polynomial section, I told y'all that's how to split it. I said FOIL is actually this, right? Y'all remember when I done that? I wrote out FOIL down the right-hand side. Oh, yeah. Sure did. Right here. Then I said, some people like to do the little rainbow arches. I tend to do it this way. Take the first term times everything in the second. Then the second term times everything in the second. I said, it works 100% of the time. No matter how big your polynomial is. I went right over there and put a try times a try and laid it out for you, did I not? I did. That's crazy I can remember those steps. Yes, sir.
The first 9 at the top of the page.
Yes, sir. Which one?
The first 9 at the top of the page, you labeled them with the wrong number.
Oh, it's okay. Miss Forster, she can't count. She's new to this thing called math.
What do you mean?
She made the sheet up. So if she misnumbered something, then it's okay. It's like me passing out papers.
Put that on the back. It's like, don't question.
Well, funny you should say that. Here you go.
Funny you should say that.
Hey, look right here. Funny you should say that. Pythagorean, look. So that would have been your back or front, and that was your what? Back, right?
I just want to take these boxes on the front and put them on the back because I don't have enough space. I need more space.
Okay. Yeah. Okay, I'll just go ahead and tell you. I have always pictorially represented this, that yes, that this is an area model, and that's the area model, and that's an area model. That is of that length. But I haven't worked with these. I've not worked with a dot. My intuition is it's using some kind of slope, is my intuition. But I will tell you, I'll nerd out. We would have done this in 8th grade like this on the dot pattern, but we didn't teach it that way in 8th grade, did we not? No. And you didn't do it when you had accelerated math in 7th grade, right? Okay, so this is one representation over here with the dots that that I'm not familiar with. I know it exists. I've seen it multiple times. I just never have worked it that way to go, oh, there you go. But I'm pretty sure that it has to deal with slope. But if I started it, it would be just one major faux pas. So, okay. No, it ain't on your back. I didn't print it out on your back. Okay. So what you're responsible for is there, right? All this right here, right? We can. We only got 4 minutes left in our enjoyment of this time. Because we take a little bit of time to go over our homework. Well, it's important to know how to multiply. Hey guys, look at this. Find the area of the triangle provided. Really want you to look at this problem. Look at this problem, number 18, ladies and gentlemen. Because you need to make sure that you're understanding something. Now, I know they think your class is about over, but it ain't. It's 1/2 the base times the what? Mm-hmm. They gonna know why y'all gonna have extra homework. Now I'm about to show you. Watch this. 1/2. What's the base? 2 square roots what? What's the height? How would I take half of 2 square roots of 3? What am I taking half of? Not the number underneath the radical, but the coefficient. So what's half of 2? What does that now become? Square root of what? 18. Which simplifies down to 3 square roots of what? 2. Ladies and gentlemen, you've got to know how to do that. Now, let's stop, drop, look, and listen. Let's create a shopping list. It's kind of like going to the grocery store. If you hit everything off your list, you'll be good when you get home. So, let's talk. You have to simplify radicals with just numbers. You have to simplify radicals with numbers and variables. You have to add radicals. In order to add radicals, first off, they must be simplified. And after simplification, if they have the like radical, you can combine their coefficients. After addition or subtraction, it's multiplication. You have a flow chart or a graphic organizer that goes over all 3 of these. Outside to outside, inside to what? Ladies and gentlemen, before we leave, I can wait. I'm a patient man. But I'm going to get my time back after the bell rings. So take all the time you need.
Hey, y'all, be quiet.
Bring your A game in here tomorrow, because I am here to tell you. We're going to test you to see how your knowledge is on radicals. Make sure that you work a problem. You can pull problems that we've worked, rework them, check them. You've got to make sure you're solid with them. Do you understand me? This recording will be up. Take care.